Okay, great. I'm Michael Mealing with Masten Space Systems. I'm the CFO. Masten Space Systems is a vertical takeoff landing suborbital spacecraft developer. Our vision is based on the fact that we believe the DCX proved that VTVL spacecraft can be operated like an airplane, and due to that, we are developing our own at a price per launch that we think disruptively creates new markets such as affordable K-12 space science, amateur space-based astronomy, point-to-point cargo delivery, and eventually space tourism. The problem that we've identified is there are several very served markets that currently cannot access any space service at all. The only space they get to access is what they watch on TV in a voyeuristic fashion. What we would like to do is be able to lower the price to a point where they can actually be involved and therefore create new markets. This is an example animation of our flight video to give you an idea of how our vehicle works, the operational characteristics that allow us to reach that price. As you can see here, we have very little need for ground support equipment. We can fly from pretty much anywhere, very low, very fast turnaround times. We take off vertically, reach between 120 kilometers and up to 500 kilometers with a lot of different options in that flight. This example right here is a Earth observation mission where the intent is to reach just above the edge, open the payload bay, and allow the payload to have a view of the Earth. And as you see here, the payload bay can open up. We have options to pressurize the payload bay, eject payloads, allow payloads to view space, to do space-based astronomy. We can also close the payload bay and provide pressurized environment for life sciences payloads. And then we re-enter tail first. Once we have reached terminal velocity, we reignite our engines and come in for a soft landing where we took off from. And as you can see, we land very close to where we took off from and can refuel the vehicle and fly again with about a 4-hour time, allowing us to fly multiple missions per day. The only really limitation is the integration time of a given payload. Allows us to do survey type science where you fly multiple times a day to run an experiment over and over again. The next slide. There we go. The aspects of a VTVL that allow us to do this are the fact you can return. Landing configuration is very similar to takeoff configuration, so your turnaround time is low. That allows you to get high flight rates, which actually produces the economy of scales necessary to create this reduced cost. Over time, once we get beyond this initial flight vehicle, we do intend on doing humans to suborbit for suborbital tourism, cargo to orbit eventually, and then humans to orbit, doing a two-stage orbit approach. Our business model is very similar to launch companies. We fee per flight. We also have other revenue streams in terms of licensing our technology, licenses for payload manuals, and some of the other technology that payloads would need to be able to do to build kits and other. One of the things about our industry is that because of the cost of the access to space, the launch providers end up being one of the gatekeepers of the emerging space industry. The market segments that we are approaching in order of priority that we're going after, we believe that K through 20 education is going to be one of our larger market segments, about 40% of our revenue. That market segment has very short lead times, usually sometimes in the order of weeks, definitely less than a year. The existing market is non-existent, and we believe that based on pre-sales that we have made and market surveys, this is going to be our largest market segment. After that comes NASA-funded research. That area has very long lead times, so it affects when that revenue actually ends up getting booked. Non-NASA research, which is university-level research, but also hobbyists, aerospace contractors looking to test articles at very low costs, are also significant revenues, but those are in a little bit longer sales lead times than education. We also are expecting a heavy initial market, but we expect that market to disappear after about 6 months of our first flights, given our flight rate, because one of our intentions is to make space accessible so the novelty does eventually wear off. But there are sub-niches of that market, such as cremated remains to space, memorial space flights, things like that, that do present an ongoing market. The forecasts that we have do not include international and eventual space tourism because of the R&D required and the time horizon on the market forecasts, but international interest in the business is significant and pretty much is actually higher than domestic interest, but is difficult to break into because of ITAR uncertainties. We feel that we can break through those, but given the uncertainties, we didn't put that into our in our financial projections. Tourism is something we get into in 2009 and 2010, and equally the uncertainties there and the time horizon, we don't include that in the upcoming projections. Without getting into too much detail, considering who else is in the room, this is our view of our forecasted EBITDA. As you can see in 2012, just based on suborbital cargo alone, we're looking at about 9.4 million per year EBITDA just on that product line. As you can tell, 2006 and 2007 is most of our revenue. One of the biggest issues in this industry is the cost of insurance. So we have some significant initial losses on our first few flights to be able to get insurance costs down, but that gets recovered very quickly. Our competition, as many here in the room would probably know most of these names, Blue Origin, run by Jeff Bezos, very quiet but some deep pockets. Virgin Galactic, which right now is partnering with Scaled Composites and the Spaceship Company, but we eventually view them as a customer, hopefully being able to sell them vehicles as well. SpaceX, going directly to orbit. Armadillo Aerospace, which presented earlier today, is one of the other VTVL competitors and is actually one of our competitors in the Lunar Lander Challenge this fall. X-Core Aerospace, which is my friend right here to the right, and one of our neighbors in Mojave, is developing a Xeris suborbital space plane. They have significant revenue from SBIRs and subcontracts from Prime, so they are revenue positive these days. Rocket Plane is developing a suborbital vehicle based on Learjet, and TGV, which is another VTVL developer besides us, Armadillo and Blue Origin, but we feel that they're going after a completely different market segment than we're planning on going. Our management team is David Masten, who was formerly with Cisco Systems and has funded the company to date. Myself, I am VP for Business Development and CFO. Came from VeriSign. We have our 3 main engineers, Jonathan Goff from BYU with an aerospace engineering degree, and Pierce Nichols and Ian Moore are our main engineers. We do have interns that come through from time to time, but this is pretty much our management team. Right now, we're a 5-person shop. Our capital requirements over the next few years, $3 million gets us to profitability, pays for continuing R&D headcount, adding a few more engineers, materials and subcontracts for building and testing production vehicles, marketing and sales campaigns, and a small additional sales staff, and filings and several other consultancies that we intend on hiring to help us with some of the regulatory aspects. Eventually, when we get in the out years, when we go after suborbital tourism and orbital development, we're looking at follow-on series and investment rounds. Exit in this industry is pretty much expected to be M&A. Hopefully, one of the primes will buy us one day. Our current status, we are complete with our vernier engine development. XA 0.1 hold-down tests are next week. We are working toward being a X-Prize Lunar Lander Challenge participant, which is this fall, October 20th and 21st in Las Cruces, New Mexico. We have filed our permit applications with the FAA and expect to hear something from them very shortly. We have begun pre-sales about 3 months ago and are getting significant interest in pre-sales from the K-12 and several other interesting customers, and negotiating channel partner agreements, and we moved to Mojave to begin our testing. And that is the end of my slides. Ready for questions? Thank you.
quickly on the reusability of the launch craft? Meaning, I understand that to keep launch costs very low. To keep very low, I would imagine that the reusability factor is fairly high. Maybe specifically to the engines or other components. Any comments relative to that?
Sure. This vehicle is meant to operate like a general aviation aircraft. The engines, our engineering process is optimized for operations lifetime before we ever get into performance or exotic thrust, exotic propellants. We picked LOX isopropyl alcohol for the availability and cheapness. The engines are built for hundreds of cycles before we do maintenance. We expect to have a small fleet of vehicles, mostly for being able to pre-position them in different spaceports around the country as opposed to having to have large amounts of spares. Given our flight rate of being able to do 8 flights per day, you can see why that vehicle has to be as reliable. And the intent is, the limitation on our ground loading time is how fast we load liquid oxygen. That's the only thing that really limits us. We don't do any maintenance on the ground except once every 100 flights or 50 flights or something like that. So it's very much like general aviation or the commercial aviation industry.
And given that there are half a dozen or so fairly, in some cases well-funded or fundable competitors in the space, what's going to make Masten stand out? And if part of the answer is this $25K cost basis, per flight, per launch, why couldn't they sort of use some of the best practices and compete on that basis as well?
2 answers specifically. One is, in addition to the 25,000, we are also for suborbital vehicle. Given that we do not have wings, and no offense to Rich over here, we're going to be targeting 500. Which is usually 5 times higher than pretty much most of our competitors in terms of our altitude. So for suborbital tourism, that means you have a much better view. We can also have a much more linger time for microgravity experiments. At that altitude, you can do, there are specific astronomy experiments that you have to do at those kind of altitudes to get above the atmosphere significantly enough. So we feel that is one of our competitive advantages, that we're planning on going much higher than most of our competitors. It's speed to market. Our first commercial flights are scheduled for next summer. Because we are not going after suborbital tourism, it's easier for us to go to market with a cheaper product, with a broader base of customers that we can then train and have pre-positioned to know our brand and know who we are and trust us, to be able to then graduate to the suborbital tourism market later. So we feel that we can actually start commercial service next year, whereas most of our competitors are still looking at suborbital tourism for follow-on years. The market and our altitude, and the channel agreements and the exclusivity we're negotiating there is one of the other aspects of it.
When I think of Cisco, I think of a company that makes routers. They also make digital phones and other things that sort of look like routers, but they don't make anything else outside of their business target. When I think of the things that you've described, it seems to me a company that flies to the limit of space is going to be very different from a company that does what you showed us in that video, which was a great video, by the way. But it needs life support systems. It needs a very different kind of marketing, very different kind of liability. Everything else is different.
Yes.
Why are you chasing two rabbits?
We don't really consider them too different in terms of just simply launching mass. We are a truck. We are going to be partnering with other companies that can actually start to help us build the pressure vessels for the suborbital tourism. There's some people in the room that actually design suborbital tourism class cabins. And so we're looking to find, eventually when we get there, looking to find a partner to do the suborbital tourism part specific to that market segment, and we will fly that as mass. The requirements for example, life science require a pressurized cargo bay to be able to do the kind of cargo experiments. So expanding that up, really for us, it's just taking the existing vehicle and making it being able to throw more mass. And that's a standard engineering extension. But we will be working with those channel partners to buffer us from the differences in those markets. So we're looking to, for example, one of the reasons we don't exactly view Virgin as a competitor is we would like them to handle the entire tourism market. We just fly whatever they want to fly.